Hello and welcome. In this lecture, I'd like to talk about the concept of variables and data types. Alright, so you should remember that a program needs to store the instructions of its program and the data that it acts upon while your computer is executing that program. So I want to just reiterate to you the concept of memory. Right? We talked about this in an earlier lecture, but I'm kind of just summarizing here why memory is important and what it is, because it's directly related to variables. So you should understand this concept of memory, right? Understand what the difference is between memory and a hard drive. Okay, but we know that memory is used by programs. When a program has to send instructions to the CPU, it's going to use memory, and when it also stores data, it's going to use memory. And a program will definitely do both of these in order to be useful. This is called RAM, random access memory. Programs store data in RAM, and they will for variables and data. They will also use hard drives. The difference between storing data in RAM versus a hard drive is when you store it in RAM, the data is going to go away when the computer is turned off or when the program exits. Now, if you want to store persistent data, you would store it on a hard drive. Programs still may use data on the hard drive, but only usually for external data, persistent data, data that's retrieved somewhere. All variables and all data in the program itself is stored in memory. Okay, so memory is, you can just kind of think of it as this ordered sequence of boxes. I was trying to find a good illustration for this to help you. We'll go over this in a lot more detail when we talk about pointers, because then you really have to understand and visualize how memory is stored. But if you think of memory as just, it's an external hardware configuration or hardware type, and it's just a little stick of memory that you can put in your motherboard. And if you think of it visually, conceptually, it's just a sequence of boxes. Each box is full will be represented by the number 1, and when it's empty, it will be represented by the number 0. And it stores binary digits. They're zeros or ones, which represent true or false values. And each box is called a bit. So bits in memory are then grouped into a sets of 8, which is a byte. So you've probably heard these terms, bit and byte. They're important when they're related to memory because it determines the size of the data. So each byte has been labeled with a number that represents an address. If you have data stored somewhere in hardware, you have to know how to access it. And just like a street address where you live, you need to know how to get access to that memory through some kind of label. So all memory bits and bytes have 8 bytes have an address. So 8 byte represents an address in memory, and it uniquely references that byte. So that's how you can access the data, and that's how you kind of want to visualize it. So again, memory consists of a large number of bits that are in groups of 8 called bytes, and each byte has a unique address. And your program will access that data usually through an identifier, but it can also use hexadecimal addresses. And when you have memory for a program, memories that use programs and memories that are on your motherboard, it will increase the efficiency of your programs if you have more memory and the memory is faster. The buses are faster. You can access the memory quicker. So 16 gigs of RAM, you probably heard terms like that. That's the higher amount of RAM means that programs can store more memory and access it quicker. And remember, programs use memory because it's just faster. If you have to store something on a hard drive, it would be much longer to access. And remember, we are executing a billion instructions per second, remember, by the CPU. So that's a lot of data that you may need to access. So how does this all relate? Well, it directly relates to this concept of a variable. And so a program is only going to be powerful if it can manipulate data. It's going to send instructions to the computer, but it needs to manipulate data. So in order to understand the different data types that you can use and how to create and name variables, you need to understand this concept of memory. Okay? And when you're writing a program, for it to be powerful, you have to then understand the concept of variables, how to create them, name them, and also this idea of a data type. Constants are types of data that do not change. They're always the same. They retain their values throughout the life of the program. So as long as that program is running, that data is always the same. Variables are the exact opposite. They're types of data that may change, and that's why it's called a variable. So values can change throughout the lifetime of the program, different values for that variable. And variables and constants are stored in memory with an address. However, it would be really, really hard to access that memory and memorize all the hexadecimal addresses. So it's a lot easier to create variables that have meaningful names. So you can give variable names that represent the memory locations, that represent the addresses. And that way you can access them and modify that data much easier. So for example, assume you want to store two values, 10 and 20, in your program. And at a later stage, you want to use these two values. What you would do with this data is you would first create two variables with meaningful names. Probably something like, depending on what the 10 and the 20 represented, but it might represent, ages. So you would say age 1 equals 10, age 2 equals 20. You always want to use meaningful names. And then you can store the value. So you create the variables with names. Then you assign data to those variables, the 10 and the 20. And I'm going to show you how to do that. Then later in your program, you can access those variables by their name to read the data. And you can also modify them later in the program to change it, as long as it's not a constant. So as far as naming variables, there are rules in the C programming language for what you can name it. In C, all names, variable names, must begin with a letter or an underscore. And then they can be followed by any combination of letters, upper or lowercase, underscores, or digits 0 to 9. So for example, I could create a variable called Jason. My flag, I, J5X7, my underscore data, another, or underscore another variable. These are all variables that start with either a letter or an underscore, and then whatever's following them is fine as long as they're uppercase letters, underscores, or digits. Here are some examples of invalid variable names. You would not be able to create variables with these names. The compiler would give you an error. If you said temp $value, the compiler would give you an error because the $sign is not a valid character, so you can't use the $sign. My space flag, that would give you an error because there's a space. 3Jason, that's an error because you started a variable with a number. Can't do that in C. And remember, the compiler checks these rules, so they'll tell you if you're wrong. Int is actually an error too. It looks normal. It looks okay because it starts with an alphanumeric character. The problem here is it's a keyword. All programming languages have certain words that have special meaning that you cannot use for names. And int is a specific data type for the C programming language, so you cannot use that as a variable name. So these are some examples of variable names that are not good. I mentioned earlier that when you do create variable names, you want to make sure they're meaningful. We talked about comments already and the importance of comments for self-documentation and understanding the code. Meaningful names are the exact same thing. If you have meaningful names in your code, it can increase the readability of the program. It's much easier to follow, and it also helps in the debug and documentation process. So use meaningful names, and we'll be doing that throughout all the examples that we go through. So once we name the variables and we have a variable, well, what about the data that's associated with that variable? That's referred to as a data type. So some types of data in programs can be numbers, letters, or words, right? We just talked about how you can have 10 and 20 as values. And you can also have alphanumeric or strings or characters. So the computer, depending on that type of data, needs a way to identify it so that it can do certain things. It really just affects the size of the data in memory, how it's stored. So a data type represents a type of the data which you can process using your program. Examples of types of data I mentioned, numbers, letters, and words. Those are represented by specific keywords in the programming language. So examples of keywords in C that represent data types are ints, floats, and doubles. And we're going to talk about these specific data types and what they mean in another lecture. But data types are important because you have to specify the data of the variable when you create it. And the data types are going to correspond to the byte sizes, depending on the operating system, the architecture of your program. So again, it all has to do with size and how this stuff is stored in memory. The program needs to know, do I need to allocate 8 bytes, 4 bytes, 6 bytes? And it all depends on the data that's being stored. And the way that the program knows how to do that is you specify a data type. There's also this idea, or maybe you've heard of this term called primitive data types. These are types that are not objects, and they store all sorts of data. In C, all we have is primitive data types because we have no objects. So everything is a primitive data type in C. Now, if we want to actually start using variables in our program, we first have to declare them. Declaring a variable means that you specify the type of the variable followed by the variable name. So you use the data type followed by the name. And this tells the compiler how a particular variable will be used by the program, and it will also understand how much data to store in memory, whether it's 8 bytes, 4 bytes, and so forth. So for example, there's a reserved word, a keyword in C named int. That's used to declare a data type of type integer. And so if you wanted to create that in your program, you'd first have to identify the data type, the keyword, which is int. Then you'd have to have the name of your variable. That's also referred to as an identifier. And then at the end, you'd have to have a semicolon, because remember in C, all semicolons end all statements. So the actual syntax looks like is like type specify or data type specified after with variable name followed by the semicolon. You can also declare more than one variable on a single line by using a comma, or you can declare variables on separate lines. It all depends, but there is syntax for comma separated variables. And C requires you to specify all program variables be declared before they're used. So declaration is basically just telling your program, this is what I have. It's not telling you how you're using it. It's just saying, this is what I have in my program. I have a variable named int. I have a variable that's going to store a decimal number. Things like that. So here's an example. We have the type of the data, which is int, and then the variable name. And here it's just x. And then we have a semicolon. Another example, if you wanted to create multiple variables on the same line, you can separate them by commas. So in this example, we have 3 variables of type int named x, y, and z. And so we're going to, when we, and this is called declaring variables, we haven't assigned any data to the variables. We just said this is the variable that exists. And what will happen in the program is the program will create those 3 variables in memory, but there's no values for them yet. You can assign a variable a value by using an equal operator. And we're going to talk about this in more detail when we talk about operators. But this is pretty simple, and you should understand it. Assigning a variable to a value, you just use equals and then the actual literal constant of the type. So in this case, x is an integer, decimal, so we assign it 112, and then we have the semicolon. That's assigning a value. And closely related to assigning a value is initializing the variable. Initializing the variable is basically having an initial value for that variable. And it's important to initialize your variables because if they don't have any data, any values associated with them, it could cause problems in your program. So you want to get in the habit of initialization. And initialization can be done as part of the declaration. Doesn't have to be. Basically what happens is when you declare the variable and you say, hey, this is my variable name, this is my type of variable, you can then immediately have the equals operators and then the value of the variable followed by a semicolon. Like, for example, int x equals 21. In that case, you're declaring a variable named x of type int, and you're also assigning it a value of 21, initializing a first value. And that's initialization. Another example, int y equals 32, z equals 14. We can do it on the same line, initialize 2 variables of the same type. Int xz equals 94 is okay to do by the compiler, but in this case, you're not actually initializing both variables. Only z will be initialized. X is not initialized. So z is going to be equal to 94. X is not going to have a value. So that's important. And we're going to be declaring and initialized variables all throughout our code. So let me just go and we'll bring up a simple project in CodeBlocks, and I can show you how you basically can declare these variables, just like these examples. So here we are in CodeBlocks. This should look familiar from our previous example programs. We have some comments at the top from lines 1 through 6. They're multi-line comments. We have our include directive on line 8 saying we're going to use standard library. And then we have our entry point to the program, our main routine on line 10. And we're not doing anything in our program. Now, again, for a program to be interesting to do anything of substance, you're going to want to create and use variables. And there's all sorts of different ways. Right now, we don't really know all the data types, so we can't really create many different types of data. We've really just had that int example. But again, just to reiterate, all you need to do is you have to specify the data type. We know int, so you type in int. And actually, with the IntelliSense and this nice integrated development environment, it displays all the other things that you can define with int. It actually completes I. If you were to type an F, you would see maybe other things completed, like a float is another data type that we'll talk about. But again, to declare a variable, you just say the data type, a valid name. Remember, valid names start with alphanumeric characters or underscores. Can't start them with digits. So here I could just say int Jason. And then I have a semicolon to end the declaration. And that's how you declare a variable. Now, if I want to initialize that variable, which you should do, during the declaration, you just use the equals operator and you specify the right type of data. So int is a decimal, so I have to say a number. I can't put a word in here because I didn't specify a word. I specified a number, and that would give a compile error. But all you have to do is specify based on the type of data and then a semicolon. Remember, semicolons end the statements. And that's initializing and declaring a variable on the same line. You could also assign values to variables later in your program. So I could just declare it, and I could actually initialize it. Let's say it's equal to 5. And then I could overwrite it in another line. I could say Jason equals 8. I want to change the variable because variables can change values. Here we're assigning data using the equals operator, and you'll notice that there's no data type on line 14. All we have to do to access that variable is specify the name to modify it. We'll talk more about the equals operator when we talk about operators. But this is the basics for variables. They represent data in your program stored in memory, accessed via variables using these naming conventions, and initialized and declared in your program with data types and assigned values. Thank you.